Okay, hi. Today we're moving on to linear equations or solving linear inequations, which is another word for inequalities basically. So we might find that the word inequations and inequalities are interchangeable. So solving linear equations, we use the same method as for linear equations except when we are dividing or multiplying by a negative number. So if we divide or we multiply by a negative number, we reverse the inequality sign. For example, just do a simple one. If I had minus 4x is less than 12, I need to divide by minus 4 on both sides. And what I'll need to do, because I'm dividing by a negative, I need to flip that sign around the other way. So I'll end up with x on this side, and I'll end up with minus 3 on that side. So whenever we divide, and the same will be the case is if we are multiplying by a negative number, the sign needs to be reversed. So that's really the only tricky bit in there. Other than that, it's going to be the same way as if we were working with an equal sign. Okay, so let's just jump straight into our questions and have a go. You're probably quite familiar with doing these. We're just going to use our normal algebra and work the same as if it wasn't an equal sign in there instead of an inequality sign. The only difference will be when we divide or we multiply by a negative number, we're just going to flip that sign the other way. Okay, so we're going to get the x's onto one side, our numbers onto the other side. So I'm going to go, we're going plus 7 plus 7. I'm going to end up with 3x is less than or equal to 8x plus, what do we got? 25. I'm going to go minus 8x, minus 8x. We get minus 5x is less than or equal to 25. So I've basically got the x's over to the left, the numbers to the right. If you had wanted to, so you didn't get a minus on that side, you could have popped the minus 3 to the other side by taking minus 3 across and brought the 18 over. Either way, you're going to end up with the same answer at the end. Now I need to divide both sides by minus 5, in which case I need to remember to, when dividing or multiplying by a negative number, we reverse the inequality symbol. So I'm going to need to do that down here. I'm going to need to flick it the other way. Okay, it's changed direction because I'm dividing by a negative number. So I'm left with x and I'm left with minus 5. And that's our answer. Okay, let's have a look at B here. So B's got two inequality signs in there. So we've got a less than or equal to 2 minus 3x is less than or equal to 20. We can solve that as a whole lot. I'm going to split it up though, and I'm going to solve it as two parts because I think that's a little bit easier. I'm going to look at the left-hand side and get rid of the less than or equal to 20 to start with. And I'm going to do a separate one by looking at the right-hand side and not having the less than or equal to 8 in there. And I'll end up with two solutions. And that's the way I think will be the easiest for us to work through. So I'm going to take 2 away from both sides here. Taking 2 away, I get 6 is less than or equal to minus 3x. And now I need to divide by minus 3 on both sides. Dividing by minus 3 on this side, I'll end up with just x. Dividing by minus 3 on this side, I'll end up with minus 2. I've divided by a negative, so I need to flip my signs around. Let's look at the next one. We're going to, again, take off 2 from both sides. So I'll end up with minus 3 is less than or equal to 18. And then I'm going to divide both sides by minus 3. And what I'm going to end up with is an x. I divided by a minus 3, so I need to flip the sign. And I'm going to end up with minus 6. They're my two solutions, but I could write them a little bit neater again. I could write them as minus 6 is less than x is less than or equal to minus 2. So I could write them like that. And you could also put them into bracket notation as well. Okay, we are now going to solve some quadratic inequations. And it says to sketch the graph clearly showing the x-intercepts where the graph is above the x-intercept, it is greater than, and where it is below the x-intercept, it is less than. So we did a little bit of that in our last couple of lessons. But the idea with these ones here, A, B, and C, we're going to need to graph them to get our solution. Okay, so let's look at the first one. X squared is greater than or equal to 4. So I'm going to take 4 from both sides and end up with x squared minus 4 is greater than or equal to 0. What you'll notice on the left-hand side is it's a difference of 2 squares. So it's an x minus 2x plus 2. It's still greater than or equal to 0. We don't need to worry about that just yet until we graph it. And now we can graph it. Where does it cut the x-axis? Well, where are our zeros? Remember, that's another name for where it cuts the x-axis. X minus 2 is 0, gives us x equals 2. X plus 2 is 0, means x is equal to minus 2. There are zeros, and it's a positive quadratic because there's no negative sign out the front. So let's quickly graph this one. Drawing some axes, we've got a -2 and a +2. It's positive, it's going down this way. For this solution, we don't need to put on our turning points, we don't need that information, but when we're properly sketching a parabola, we would need to pop intercepts down there and turning point values. But for here, we're looking at where is x squared greater than or equal to 4, which is the same as where is x squared minus 4 greater than or equal to 0, where it's greater than or equal to 0 is above. And we need to also include those 2 points because it says equal to 0 as well. So that happens when x is going to be less than or equal to -2 and where x is greater than or equal to 2. And that defines this point upwards and this point upwards as well. Let's do our next one, part B. Okay, x squared minus 2x minus 3 is less than or equal to 0. We need to factorize those and pop that left-hand side into brackets. Remembering when factorizing, we're looking for numbers here that will add to -2 and multiply to -3. That will be a -3 plus 1, because -3 plus 1 is -2 and -3 times 1 is -3. We can work out our zeros, where it cuts the x-axis from there, setting each part to 0. X minus 3 is 0, gives us x is equal to 3 as a root or a 0. And this second part, x plus 1 equals 0, will give us x is equal to -1. Let's plot that parabola. And that's year 11 work, so you should be fairly familiar. If you need to stop the video and have a look at that yourself, do that now. Otherwise, I'm just going to go ahead and put our points on there now we need to know which way it goes. We know it's a positive parabola because we don't have a negative out the front. So a positive parabola looks like this. And we are looking at where that graph is less than 0. So it's in here. It will not include the -1 and the 3 because they are equal to 0. So we're in between the -1 and 3. We're less than 3 and we're greater than -1, but we don't want those equal signs under there. So we don't have them up here. They don't include those points there. Okay, we are nearly there. Okie dokie. So let's rearrange our next one. 10x is greater than or equal to -2x squared. I'll get the 10x over to the right-hand side. I'm not going to. I'm going to take the -2x squared to the left-hand side. Then I don't have a negative to deal with. And that's a little trick that I find really handy. If we don't need to deal with the negatives, let's not. You can't just make them disappear unless it's mathematically appropriate. But in this case, we can. Okay, so I've got 2x squared plus 10x is greater than or equal to 0. Now, I need to factorize that. I can't do it the same way as I did in part B, but I can see that common to both of those terms is a 2 and an x. So I will still have, if I factorize out by a 2x, an x plus 5 in my brackets. Okay, we're nearly there. Let's find our zeros again. Zeros, roots, or where it cuts the x-axis are all the same thing. We've got 2x equal to 0, so that means x is equal to 0. And we've got x plus 5 is equal to 0, so x must equal -5. Okay, so let's graph it. Now, because this is the function that I'm working from, I'm going to be graphing this function, 2x squared plus 10x, which is the same as this one here. So don't go back and think that it's a negative here. It would have been if we had taken our values the other side, but we would have got a different solution. Not a different solution, but the graph would look different. But we've done it this way. So we're going to look at our zeros as 0 and -5. Okay. In this case, if I was to multiply this out, I'm getting a positive parabola. Okay. They're my zeros, and I want to find out where that is greater than or equal to 0. So I want to find where this is above the line here, and it will also include those points at the bottom. So I want values of x that are less than or equal to -5 down here, and I want values of x that are greater than or equal to 0, which is this part up here. So I'll just scroll down to the next page in your notes, if you could do that too. And we're looking at solving absolute value inequations or inequalities. Those words will be interchangeable for us now. So we replace the absolute value sign with both the positive and negative version to solve. That's really important. Okay, and this is what we've been we've been doing, but I found that in our last assessment task, people did not do that. So what we're saying is the absolute value of a function, if it equals a, we don't know if that function inside is equal to a positive value or a negative value because the absolute value signs take away the negative. For example, remember the absolute value of minus 2 is 2. So we don't know if that number in there was a minus or a plus because the absolute value of 2 is also 2. So we could have a positive or we could have a negative value. So we need to have a look at both of those. Let's go and look down at our functions here and work them out. It says solve and sketch. So when we see an absolute value, we need to look at both the positive and the negative version. So I'm going to take it as x minus 2 equals 4 is my positive version. Then I'm also going to take it as minus x minus 2 equals 4. So x is equal to, if I add 2 to both sides, 6. I'm going to multiply this out, so I get minus x plus 2 equals 4. I'm going to get minus x is equal to, take away 2, 2, and divide by negative x is equal to minus 2. These are my values. Okay, so we've got our two values, and we want to sketch those. We want to just sketch them on a number line. And let that get out there. Okay, there's going to be 2 points on the number line, so I don't think we'll bother sketching those in there. Let's have a look at the next one. Okay, the absolute value of x minus 7 is less than or equal to 1. We need to solve that one. We need to look again at the positive and look at the negative versions of this inequality. So I'm going to take it as x minus 7 is less than or equal to 1. That's our positive version. And our negative version, I'm going to take as minus x minus 7 is less than or equal to 1. Now, like I said previously last year, I want you to take the positive and the negative on the side that has the function in it. I don't want you to put the positive or negative on the side that has the number by itself. I just would prefer it if you did that way, and it will work all the time nice and easily that way. Okay, let's solve this one over here. So let's go and add 7 to both sides. So we'll get x is less than or equal to 8 is our first solution. Let's multiply by the negative on this one. So we get minus x plus 7 is less than or equal to 1. Let's take 7 from both sides. So we get minus x is less than or equal to minus 6. And now we're going to divide by that 1 there, minus 1. So if we divide both sides by minus 1, that sign will flip around the other way. We'll end up with x is greater than or equal to 6 as well. And we can plot that one on a number line. So we've got 6, we've got 8, we've got coloured in circles. And we know x is less than or equal to 8, so we're down that way, and x is greater than or equal to 6. So we're in this range between 6 and 8 here. Okay, if you need to pause the video at any time, please do that. I'm trying to shorten this video a little bit and go a little bit faster. So let's look at the positive and the negatives of this function here, or this inequation, sorry. The positive is 2 minus 3x is less than or equal to 8. This stays as it is. And I've got my less than or equal to 8. My negative one is going to be minus the 2 minus 3x is greater than or equal to 8. Let's solve this one by taking 2 from both sides. So I'll end up with minus 3x is less than or equal to 6. I now want to divide by minus 3 on both sides. I will need to flip my sign around because I'm doing that. I will have an x and a minus 2. So again, you need to be careful that you're flipping that sign or you will get an inequality solution that is in the wrong direction. The negative sign is minus 2 plus 3x is greater than or equal to 8. Let's add 2 to both sides. So I'll get 3x is greater than or equal to 10. And then we're going to divide by 3. I'm not dividing by a negative 3, so my solution doesn't need to have the sign changed around. Okay, likewise, you could graph this on a number line, and you can go ahead and have a go at that. Okay, now that's all our questions for 2D. I'll also pop a couple of harder ones in the OneNote on a little tab on the side under 2D, but you can go ahead and have a look at working through those questions on 2D now.